Good morning, and today I want to talk you through some new features in Python. So Python 3.14 was released yesterday. I just refreshed my browser and I came across that Python 3.14 was now official. So that's just been released and it's got a number of interesting new features. But there's one particular feature that I want to draw your attention to. So whenever I see there's a new version of Python, what I do is I'll always go to the documentation and I look at what's new in Python 3.14 in this case, because that introduces a couple of new features that you need to learn. So for example, in previous releases, we had things like ordered dictionaries becoming standard, or the match syntax, which is used as a substitute for things like switch statements, but it's much more powerful than that. But today we are looking at Python 3.14. And they have a number of things: deferred evaluation of annotations, multiple interpreters in the standard library, and a lot of other things here. But what I really want to draw your attention to is template strings. Now, what's interesting is that template strings have actually been available in the standard library since way back, version 2.6. And what happened is those were an old way to actually write, add templates, to have templates such that you could have placeholders in your text. And I'm not going to show them here. So this is the old one. This is the I think the older one is somewhere. I've opened it somewhere, but that doesn't really matter. So let's take a look at template strings. We're going to walk through some examples, and then we're going to answer the question, why should you care about template strings? And it just struck me why we should think about them. It's not obvious when you look at the documentation. So the author of this was probably someone who was working with strings a lot, and they found that they were always writing functions that had to somehow work with formatted strings, but they didn't really have a handle on the parts of the string, and that's where the template string really shine. So let's turn here to the right. I have installed Python 3.14, very fresh, as of, it was released yesterday at 8:20. I'm running this on a Mac. And this is an example that they provide here. So the example on the left of the code here, where they show you have, let's say, a variety variable, which is called Stilton. And then you create a template using a T as the beginning before the string, literal string delimiter. So it works exactly like an F string, and you put your variable variety inside. And when you check the type of this template, it'll tell you that it's a string.templatelib.template object. Okay, so fine. Now that we have a string object, what can we actually do with it? Well, you can actually run a list on the template and it'll show you the sequence of components. So it gives you a sequence of things inside. You have string literals, and then you have these things called interpolation objects. So this interpolation object has the value of the variable, the name of the variable, and some additional other variables here, which are set by default to none in the empty string. And then of course, you have the remaining part of the string literal in the sequence of the string. So you can imagine a situation where you write a function. So this is a really corny example because it doesn't really bring out how to actually use it. But later on, they actually talk how to do this. So here we have, what we'd like to do is you want a function that prints all the interpolation objects in uppercase and all the literal objects in lowercase. So you write a lower upper function, which takes a template object or template variable, and it can iterate. Because it's a sequence, you can iterate over the parts, okay? And then you can later on return the parts. You make the final string. So here we create a list, literal, called parts. And for each part in the template, we check, is that part an instance of the interpolation object? If it is, then we are going to insert into the parts list the string value of the part. Okay, so you can actually get the string value of the part, and we're going to convert it to a string, and we're going to uppercase it. Okay, otherwise just put it as a lower string. So everything, even this T at the beginning for this string literal, will be turned into a lowercase. So, and then at the end, what we return is the string joined with empty string. So we literally just give it back the way it came to us, but now as a string. So here's an example. You have a name variable called Wensleydale. You have a template, which starts with a T, and you have Mr. Name. And then we want to assert that it'll have lowercase for the string literals and uppercase for the name variables. And that's what it gives you. So that should actually pass. So let's look at this example that I have here on the right. This is directly from the documentation. So again, we have cheese. We have a cheese variable called camembert. And we have the template, which has starting with a T, and we have R. We do have cheese, and we create a template out of that. When we check exactly as we expect to, we can see what are the attributes on this object. You see, most of them are just a standard add class and so on and so forth. The only new ones that we are interested in are let's just make sure that this is properly aligned. We have an interpolations attribute. We have a strings attribute, and we have a values attribute. So let's look at each of them. So we can check the strings. It gives us a tuple of the strings within it, only the string components within it. And then we can check what are the interpolations. Remember, we had this interpolation object. Well, we only have one interpolation object, which has got a value of camembert and a variable called cheese. So it keeps track of both the value and the variable. And then we check what are the values. Well, we have camembert here. Now, can we convert this to a string? Yes, we can. So here we've actually stringified the representation of this object. So if you had to create it literally, we'd actually get a template class, assign to it strings, which is this tuple here, and assign to it this interpolation here. There's only one interpolation, but here we have a sequence, a tuple sequence of interpolations. And what if we try and print it out literally? It just shows that it's a template object, exactly the same repr, but not as a string. Can we print it? Again, it's just coming out exactly the same. So here's the $1 million question. What is the value? What is the value? So I asked ChatGPT, hey, tell me, how can I actually use it? How can I actually render it? And it hallucinated. It hallucinated and told me that there's a render method. And as you can see here, very well, there's no render method. So that's actually false. So this is a very good case where you need to be careful what you learn from ChatGPT. But why should we use template strings? And this is where they shine. So here's an example. They say that imagine if you had a HTML function, and this HTML function was responsible for assembling attributes with a template. So you created a template called T, which took an attributes object, which was a dictionary. And then you could assert, this is now like if you're running a test, assert that whenever you have HTML and a template, the template, it will give you back a properly formed HTML image object, image tag as a string. So this is how we use them. That whenever you need a template, you will need a corresponding function that does the rendering. And that's a key thing. Imagine if you had a lot of templates which you needed to fill out, but you knew that you always needed to fill them out according to a certain pattern. But you don't want to use string because you're not just stringified. You don't know what the values are at when you're writing the code. So you know the values will only be evaluated or be present at runtime. That's where this shines. So you will have a function like an HTML function that will then do all the heavy lifting, always give you the strings that you need. And that's why they say this will be so powerful for DSLs, domain-specific languages. So if you're working on any DSL, you can then use templates and then you'll just fill them out at runtime. And that is a lot of power. So this is the reasoning behind these templates, string literals, and this is how you use them. Thank you very much for your attention.